So, frohe Weihnachten, John. Aus Düsseldorfer Weihnachtsmarkt. I promised you a cold open, and here I am out in the cold. I'm here in the Altstadt of Düsseldorf, where they have some of the Christmas markets, kiosks set up where you can get about anything you want. So yeah, that's my cold open, and
looks plenty cold.
A little bit of festive spirit, and we'll be going back indoors in a little bit for the full video, but I thought you might like a little bit of atmosphere and bright lights.
Hey, y'all, it's Dr. Know-It-All. I am once again with Dr. Scott Walter. He is on vacation. I am on a quote vacation trying to get our house. Oh man, it has been a rough couple of days. Dumpster full of stuff, Goodwill full of things. Anyway, so we are taking a break because a break from our regularly scheduled stuff because we are both so excited about this video that Sandy dropped. This is, I don't know, Scott, have you ever seen anything else publicly made that goes into this much detail about cutting edge factory work?
No. I mean, I sort of seen some of the stuff, little bits and pieces of a few of these things, but not all of that.
Right.
And certainly it's very difficult to get into these factories and actually be able to film it, let alone produce a video that you then release.
Right.
But before we get too much into it, I've got my ugly Christmas sweater on here.
You definitely do.
The Charlie Brown Christmas tree back here, which we haven't quite decorated yet. It's real. And there's one thing is there's already a present under the tree, John, that you might want to take a look at.
Oh yeah, what is it?
It's way down here.
Is it
way down
Gigabeer?
here. Let's see.
Oh, I think it is. Dun, dun, dun.
If I can, there you go.
Ooh, very nice. And I've got my mug is over there from the other one. One of the mugs is over there.
Same shape.
Yeah, there we go. So it'll be perfect. We will have a toast. We'll make sure that
yes. Yes. Right. Well, we could almost do it now because I have that one, but we'll do it. We'll wait for another day.
So so we are obviously, as always, please watch Sandy's full video. It's got more stuff than we're going to cover because we're going to skip around a little bit, but this was very exciting, and a huge thanks to Tesla, also to Munro and Associates for publishing this, and for Rich Rebuilds for I guess organizing it or something like that. I don't know how he did it exactly, but that's pretty amazing stuff. So without further ado, let's jump into this. And so we are about 43 seconds into the video here. And so this is right where Lars tells, this is Lars Moravi, who is the, what is his title? Chief engineer, head of engineering, whatever.
He's like, was a vice president of production or something like that.
Yeah. So anyway, he's the real deal, but he starts talking to Sandy right here about recycling. And of course they have all these gigantic stainless steel blanks and everything, and they obviously need to recycle it, but there's a catch to all of this, which he talks about right here.
Recycle everything. We had to make a separate scrap yard for the stainless. So this is just a scrap yard for the stainless coming out. We'll go out the door over here. We're about 80% utilization on the painting. Yeah.
80. That's
So that part was that was worth calling out because Sandy's mind just went. It happens several times in this video where you see Sandy's mind just explode from the information.
Right. Yeah. And I think what they mentioned there is, remember they get the blanks that are coming out and then they're cutting them.
Right.
And he said that they're using nesting. That's why they're able to save a lot of material.
Right.
And for those who don't quite understand nesting, if you've ever, well, it's Christmas, making Christmas cookies, you get the batter out, right? And then you have this form that you kind of go through. And if you're really inefficient on how you put that form down there, you're going to not have as many cookies and you're going to waste a lot of batter and have to recycle it and do it again.
Right.
So the whole idea is to nest your parts as closely together that you use as much material as possible. And Sandy's a bit blown away that they were able to do 80% because I think he said it's usually down maybe around 60% or something like that.
Right. Yeah. Yeah. And Lars immediately responds after that and says, well, if you suck at doing what you're doing, then it does. But anyway, so
it's amazingly high.
Yeah.
Well, they're pretty square panels.
Yeah.
So they're kind of easy to nest.
Yeah. Well, I guess so. Yeah.
It's
true.
60, 70, if you're making Christmas cookies, which are square, it's a lot easier than the ones that are shaped like a Christmas tree.
Right. And they're going to talk also, we're just about to go watch them unroll the stainless steel. And by the way, I want to give both of us a little bit of kudos because we did suggest that they were doing laser welding on the door, and we're going to get to that part where they do the laser welding.
That's going to be interesting. We were kind of right and wrong about a few things on there. Yep.
Yeah, yeah. But anyway, so instead of getting platens of flattened stainless steel from whoever makes these things for them, they're getting, and you can see it, I believe, in the background right in front of them, there is
they're coils.
Yeah, they're coils of stainless steel. But the problem with that, of course, is if you've ever, I've actually got this because I just found this thing when I was undoing the house. And, you know, this came coiled up and it doesn't really want to uncoil. And that's just a, you know, small cable.
Oh, yeah, it's very difficult. So you basically, it's coming like aluminum foil and they have to unroll it. It is possible to come flat. I wasn't sure that that thin would come flat. I've seen them in shipyards where you're seeing like 3/4 inch or inch flat plate that will come out that way. It's not going to come out wound up. But this, they're able to bring the coils, but now you got the problem is like unwind the thing, it's not going to stay flat. So you need to have a flattening process in there. And this is what's rather amazing is what they're about to show.
Yeah. And let me see if I can skip forward a little bit here and find the part where they get to the, well, so we get to see the coils and this is also interesting because Sandy specifically asked later on if they weld the ends together to, you know, have it be continuous. And he's like, no, we just have them custom made to the right size so that we just cut the pieces we want, and we might end up with a tiny little piece at the end. We throw that away and then just start.
Right.
So, yeah. So there's no need.
Yeah. Sometimes you will see that with rolls that somehow get spliced together to later on go through. And sometimes I wonder if it's really worth the effort, but you know, otherwise you have to rethread the machine and everything else. And so that's, you know, so the idea of just kind of keeping it going to make it continuous.
Yeah. For all the old people, imagine threading those analog cameras when you had to put the film into it and twist it and get it started and all that stuff. So, you know, it's that kind of a thing, except with multi-ton steel cable coils instead. So, yeah.
Well, the whole vehicle plus the crap that comes from some supplier or something. Hi, good. How are you? Good meeting.
Yeah, so he's the lead engineer here for our straightening line. This is Dan. He's our head of shopping stamping.
Hi. Nice meeting you.
So we're just going to walk you through real quick. We'll come over here and we'll look at it. But basically, we get coils in, we feed them in on this side, and out on the other side comes micron precision level blanks.
Right. And that's worth pointing out. Micron, I mean, Elon said that in that open letter, or whatever, the leaked letter. He said we needed micron precision, and they say that multiple times in this tour. So and this is not, that's not simple. I mean, we're talking about cutting things.
No, it's not.
It's just crazy. And also the amount of care they take, and I know they specify A and B sides. So when they talk about that, the A side is the side that you can see, and the B side is the inside where you can't. So they don't care about scratching that, or, you know, if it gets dinged up a little bit, that's not as important. So anyway.
No, turns out Rich had me covered.
So this is the first of its kind laser blanking line. What it does is it takes coils, it unwinds them, and it's taking out the internal stresses from the raw material. It's passing them through something called a leveler. All it's really doing is it's got a bunch of work rolls and they're moving up and down, and they're flattening the part.
So I think that's worth pointing out because that's just crazy.
I mean, so you're going to do these different rollers, right, that undo it. And I think there is a YouTube video out there from Schuler that sort of shows a little bit of what that process looks like.
Right.
And of course, they're using probably normal steel, and this is stainless steel, so it's going to be a little bit trickier to try to get that process to work. And the other thing they're afraid of is that when you're doing that, you're potentially working the material, which just means you're going to be changing the properties of it. So you have to be very careful how much you do it.
Right, because I think that's something that maybe if you're, and certainly I'm not an expert in material science, but crystalline structures, if you put them under, because you might think like, oh, just, you know, roll it out and squash it and it'll.
Well, you've heard of things like cold roll and stuff like that. Those are designed to intentionally change the properties of the material that you have.
Right. Right. But it sounds like pretty much they don't really want to change. They're happy with what they have here.
Right. They're happy. It came from the mill the way they wanted it, and they don't want to make any changes to it.
Right.
So they have to be very careful.
They have to flatten it, but they have to not flatten it too hard. So yeah, so clearly there's a lot of experimentation that went on. They talk about this. They're like, oh yeah, we started with 3 millimeter stainless steel. We worked it down to 1.8 and all this kind of stuff. So yeah.
Want to be careful that we don't work the material too much, because you do something called work hardening, and then you shear the part later on.
Yeah.
Right. So this was a special development as well. This is something that's primarily used in mills. So we actually source it for a blanking line.
So just out of curiosity, why don't you let us know the thickness I think I know, but I'd rather have you say it. What's the thickness of the material?
So we have two thicknesses. Our doors are 1.8 millimeters thick, and all the other parts, like the sails, the hoods, are 1.4 millimeters thick.
1.4.
Correct.
And we worked hard to get that strength up on the stainless because the original we were about 2.53, but we actually increased the strength of the HFS over time. So we're able to get, while doing that with the ductility for forming, we're able to still get that strength and bulletproof toughness
Yeah.
with having a thinner material.
Cool.
Correct. So this is actually designed for 3 millimeter, but it's good that we're not using it.
So anyway, obviously they're very proud of this. They have been able to reduce the thickness of the stainless steel by almost basically half, 1.8 and 1.4. And later on, they talk about how Sandy talks about, oh, you just want it for bulletproofness because the doors are 1.8 and the rest, everything else is 1.4. But it actually turned out that it was side impact. So the stiffness of the doors themselves with the extra thickness, the extra 0.04 millimeters, 0.4 millimeters. Anyway, with that extra thickness, it's stiff enough to take up 75% of the impact of vehicle side impact, which is very impressive. I have a feeling that being inside this truck is going to be one of the safest places you can be on the road.
Probably.
Yeah, I mean, especially because not just the exoskeleton, but also the door, like all those door frames and everything, all of that stuff is stainless. So it's just a massive block of stainless steel with you inside of it. So it should be pretty darn safe. But anyway, very impressive stuff watching how they're doing this. And I believe we move on to the laser cutting next here.
That's where we started.
Yeah, correct.
So let's see if we, oh yeah, here we go. So right away we get
It's
to
actually
that.
designed for 3 millimeter, but it's good that we're not using it.
That's where we started.
Yeah, correct. So, oops, sorry. This shows a good overview of the line. So you have the uncoiler, as I explained, where the actual raw material, we call that a coil, is being loaded. It's being unwound as we speak. It's going through the leveler or straightener, depending on what you want to call it. Then it's going into the laser booth, which is what you see right over there. It's airtight, light tight because of emissions and whatnot. And these are two lasers working in
Okay,
tandem.
it's
And right
airtight
now
and
what's
light tight.
being-
That's very important. For light tight,
Right.
it means there's always a possibility of a reflection somewhere in there that could come out, and someone just happens to be looking in the wrong direction at the wrong time. They could be blinded. So
Right.
those things really are light tight. There's no way light can get out of those cells.
Yeah. And the airtight is also very important too, because as you're cutting the metal,
There's fumes. Yeah.
there's fumes coming off of that. So they have to have some sort of a fumigation hood that pulls out all those toxic metals. So I'm trying to look. At some point he goes in here. They actually show a little bit of a close up on the camera,
It's cut at
and
1
it shows.
millimeter. This was a special development with Tesla and Schuler.
So just again, you bring.
By the way, big shout outs to Schuler and Kuka and Fanuc and one other one today. I noticed
It was Trump. Yeah.
Trump.
No, I think the three were Schuler, Trump, and Kuka. That Sandy are Sandy's three favorites.
Yes, they are. I just meant that Lars and team, they, so anyway, it was nice shout outs to all those companies. It was very cool. So yeah, but anyway, so these guys, it looks kind of like an inkjet printer with the big cable that runs along the side.
It's basically 2-axis. Yeah, it's 2-axis because it's a 2-axis problem.
Do you have any idea? So he said there are two working in tandem. So do you have any idea, like, is one cutting from the bottom and one from the top, or one cuts?
I think maybe they just have two to be able to do the production rate that they need.
Oh, so they're like one's working on one side and they kind of work their way to the middle or something like that. So,
or are they just cutting different blanks? I'm not sure. I mean,
Oh.
they could potentially be working together. Are they two on the same beam that's there?
He said in tandem. I could only ever see one when I watched it. Like you can actually
just
see
wondering
some arcing and stuff.
There may be maybe there are kind of two in there, and the two different blanks kind of slide in, and it's able to cut them at the same time.
Right.
In one coil, the coil becomes empty.
There it is. Yeah, so you can see that really quickly. That thing's like bang bang.
You do
That is a very
tailored
powerful
blank.
laser. And I assume it's cutting right through that just that quickly. Just zoop.
It cuts really quickly and very precisely, of course.
Yeah. And of course, when you think about that precision, because even a laser has some width. And so when you're cutting it, like, I don't know, it's not a millimeter, but let's say a 0.5 millimeter of width, that means that you have to figure out what the give is.
Yeah, that's what they call the tool cutter offset.
Yeah.
So you have to account for that and know that what you want your final shape to be, and you
Right.
compensate for that. Yep. You have to do that with milling heads and everything else as well.
Right. But the amazing thing is that we're not talking about millimeter precision. We're talking about micron precision. So
Yep.
that's, you know,
Yep.
if it was millimeter precision, it's like, yeah, okay, people do that all the time. But this is like a couple orders of magnitude higher than that or lower than that. So yeah.
From the old, well, what's left of the coil and the new coil, are you welding?
No,
Or do you-
there's no welding.
Yeah.
So that,
When we run out of material, we end the blanking, then we put a new roll in.
For a new rolling. So we actually have different coils for different products. So what we really do, and what's beautiful about this line is, if you think of a fender, normally on a 2D flatbed, yeah, you can get 2 fenders,
Yeah.
but this gives you tighter nesting. So you can get a fender after a fender after a fender,
yeah.
and you can optimize the width. So this,
Yeah, so a couple of things there. Number one, what you were talking about, the Christmas, I think that's a really good, the Christmas cookie, like
Yeah.
analogy.
Mhm.
Perfect. So you work the shape out until you get it right. But then also, as we could see from the rolls, they have different size rolls for different parts. The fenders are one width, and the hood is a width, and the doors are a width. So they whoever's supplying them with this steel is supplying
Mhm.
these rolls exactly.
At different widths, depending on what they need. Exactly. So they
Yeah.
don't have any waste on the sides.
Right.
Because you can imagine lengthwise, you can cut them as close as possible, but if sometimes
Right.
they're shorter or wider, then that could be a lot of wasted material. And instead,
Exactly.
they're just saying, just run the coil through the width that we need for that particular, set of blanks that we need to produce. Mhm.
Right. Which again is very impressive, because that means that they're obviously, because this isn't the kind of stuff you order it and it comes via Amazon Prime the next day. You have to there's a lot of lead time to get to a particular
And the
chemistry.
supplier has to be agreeable to creating
Right.
them in
Right.
different widths. Sometimes they just say it only comes to this size. That's it. Deal
Yeah.
with it.
But I mean, this is already bespoke. Nobody knows exactly what this
Mhm.
material is. It's obviously an exotic stainless steel, but so somebody's building it somebody's making it for them to very high precision, and they're making it at these specific widths for Tesla. So these are all, it's not just Tesla doing this. There's a lot of, and you heard them, they said that, Trump worked on that, the air bender thingy. And I think also Schuler, they said specifically they'd worked on that laser cutter.
Schuler for this line. Now, this line is ridiculously long.
Right.
And all the different steps that they have to go through. It's really something else. And again, Schuler has a video showing the entire process, and you can just see how it feeds from one part to the next, to the next, to the next, to the next stage.
Right.
It takes up a lot of room.
Yeah. And they interestingly enough, they go upstairs, and so as we were speculating to some extent, they pull parts up to the upstairs and they work on them up there for part of it too, to reduce just the length of this line. So
improves the scrap utilization for the overall.
So does that mean that the coils are tuned to the parts?
Correct.
Okay, and that's why you don't have to weld anything together.
Correct.
Okay, good.
Let's go check out the blanks at the end of the line.
Yeah.
Hello, how are you? Good, how are you?
I'm gonna fast
This
forward
is one
a
of our
little bit
transfer
here.
presses, the smaller one. We just make small
Okay.
parts there. We actually insource about 70% of our stampings for Model Y and Model Cybertruck.
Wow.
It's quite
Well,
a bit.
when I did the study on why we should use castings,
Yeah.
I did that study cost me a lot of time.
Yeah. So this is just separating the good parts from the bad parts.
Okay.
So because once more, as you saw in the laser, everything's being cut on one sheet. So the good parts, like I said, are being separated. The bad parts actually go right down there. And that's
Yeah.
what you see. It's going
Right.
underneath and then going
Right,
up into
yeah.
that
That's
scrap
the
house.
Scrap.
So Scott, what do you think in terms of the scrap house? Like, is that going to go straight back to whoever manufactures that steel and they'll just remelt it, or is it going to go?
Yeah, I think so.
Okay. Okay.
I would think that's probably the idea. Is it could go back and be reused.
Yeah. Okay. Okay. So the chemistry of it isn't going to change that much, or,
Yeah, I would think it would be easier to work with that than the original,
right.
where you might be having to smelt it from original ore wherever they are sourcing that from.
Yeah. Okay. Okay. So yeah, that's what I suspected, but I didn't know for sure. So that makes some sense.
Alright.
Scrap in there. Yeah.
All right.
I'm going to go through
Let's
this a
go
little
down.
bit faster here. There's some.
You see, we're stacking them here. And this is
Because
how we
what I
transfer
think he's talking about is that they are
Right now,
looking
that's
at
what
all all the blanks that are produced, and if
Yeah.
one of them doesn't pass some sort of inspection process, they just reject
Yeah.
it.
The other thing that's
I don't think he was
amazing-
talking about scrap at that point. When he's talking about good and bad parts, it means like one of the parts
but
did not.
still, I mean, you're
Yeah.
recycling the bad part.
Yeah, you're recycling the bad part. Yeah, yeah.
But this, if I'm not mistaken, this part, he actually shows a whole bunch of these things stacked on top of each other, which was a little bit mind blowing because you think about if there's any kind of sideways motion, they're going to get all scratched up and everything. So
Yeah, and that's what they were concerned about, is just to make
Yeah,
sure
right
it comes
there.
down and lands flat.
yeah, yeah. So they talk about that explicitly, and as they say, this is hard freaking steel. There's another word, but it's HFS.
So what am I looking at here?
This
You're,
is
you're
just a
basically
storage.
just carding them, right? Bringing it together.
Correct. So overhead conveyor belts, parts actually
And
come
then
through.
come see it
Look at
drops
that.
one,
Yeah.
and we just stack them up. It's very important we don't. The only thing that really can scratch HFS is HFS.
That's right.
So we got to be careful when we put it down that we're not
Yeah.
rubbing it
Right.
against each other.
Yeah. That's one of the other things that
Exactly. The only thing that can
most
scratch glass
companies-
is diamond, right?
Right. Yeah. So, and of course, that's the one problem with this stuff is if it does get scratched, you're gonna have to chuck it. So it's got to
Yeah.
look really good because there's no paint to cover it up. You can't prime it. You can't do anything like that. It's just that's what it is.
will have the stuff coated. It'll have a plastic film, and you don't.
No, correct.
So this is kind of big stuff all by itself.
Correct.
Yeah, so these are the different blanks, yeah?
Yep, different
Yeah.
blanks, all within accuracy. Tailgate, fascia, hood, doors.
Jeez.
Forgot
Excellent.
about that for a second. And then we have a measurement system. So we're producing hoods.
So that's something you'd probably want to
typically we have
robotically
a
also
periodic quality.
remove off the top when you're
Right.
taking them out,
Right.
just to make sure they don't get scratched as well.
So would you do that with a vacuum or with? I guess you do it with a vacuum.
Yeah, probably a vacuum gripper of some sort. Yeah, so you would have some sort of automated system for being
Right.
able to pick them up.
Right. It sounds like they are not testing every single part here. It sounds like this is a statistical sampling. that
Could
they're-
be. Yep.
Yeah.
Mhm.
But it's the other thing I was going to say. Well, anyway, so
Check. So we'll take the part,
Like-
put it on here. It's just a nice fancy 2D light scanner. And
Yeah.
what it does is it compares the cat that we're
Right.
cutting to in relation to what we're actually.
so this
Yeah.
part's
Right.
pretty cool.
So it's like a giant optical
Yep.
comparator.
So just watch your eyes, everyone.
Yeah, it's going to turn on.
yeah.
Takes a picture. Hopefully my arm didn't get in the way.
No, dude.
No.
You can even sit on it and it'll be fine.
Yeah.
All the points.
Yeah, so all the points are within spec. That's what this is measuring the outer contour.
But I think
You
they
see this level
show.
of micron precision here? You know, Elon's been
Yeah. Okay. So I believe it's really hard to see this, but I believe all those little things are just little flags that say what the numbers are, like numerically.
What the error? Yeah, what the error is. Yep.
So it's
Yeah.
very impressive stuff. So
7 microns.
let me zip through a little bit here. Okay. Now I knew that was coming.
Brought to you by the three.
This is very interesting, by the way. but- Sounds great. Again, I wonder how much these guys paid for this.
Must be paying a lot.
With our 2D
Yeah.
laser allowing more we have to produce very parts very easy sales that have
Again, as an example of an automated system for picking up the sheet metal.
Right. No, so it's a perfect ad. It's really good for this. Oop, okay.
Whether you're looking to
Oop.
source metal stamping,
Gosh, it's a long ad. Okay, there we go. Okay. All right. I can't remember what the next part is, but we'll find out in a second. Melt center.
Okay, good.
So this is our die storage area, and I asked him to open up because the inner panels are also stainless, but they're formed, right? Because
Yeah.
the best way to get section is to have an inner and outer, right? You get a lot more
Yeah.
section. So forming
Okay, so that's obviously important there is that you've got the outside part that you can see, but then of course there's the inner
The
part
inside
of the
part.
door. Yeah.
Right. Now we knew the door had an inner part,
Right.
but we assumed because they looked to be stamped
Yes.
that they must have been aluminum.
But they're not.
They're not. They're stainless steel.
That's
So
crazy.
I mean, the whole thing was,
absolutely
but it's
crazy.
really hard to stamp this
Yeah.
HFS because it is just so freaking hard.
Yeah.
So how are they doing that? And it's rather shocking how they do it
Right.
when we learn about this.
So yeah,
This as an A surface is kind of hard because
Okay.
you get, drag
again,
marks,
A
whatnot.
surface.
And so
is
we had to
the
work
part you
really
can see.
hard on this process as well.
This
So-
is our front door inner.
It's two out die. And you can see this coating. It's a. Well, we went through a lot aluminum bronze coating here in the inserts to make sure that we don't get those drag marks on the stainless itself. And I think we have the world's fastest, first only high-speed A-class surface stainless press.
We're making
It's
10
handling.
strokes per minute over here. That's it.
First only, they said. Okay.
Yeah, I know,
So
right?
it seems like they're doing it in one shot.
Right. And
And the other thing that's shocking is what they coated it with, and that is bronze aluminum.
yeah, which I guess they're
Okay.
just sort of repairing as they go, right? That's what they
Yeah,
said.
yeah, they have to. So they probably have something really hard underneath it to be able to do it. And then they have a coating of this on there because the only thing that you can scratch it with is with something of the same hardness. So you put something that's
Right.
softer on there.
Mhm.
But that kind of goes against your rational thinking. You say, yes, but if it's soft, you won't be able to get the forming, right?
Right,
Because
right.
it's going to be too ductile. It's going to wear out really quickly. So it's like, well, wait a minute, how can you make it out of material that's absolutely crazy? And of course, we find out, and we'll let Lars sort of say, how many cycles are able to get out of it. Now, normally, the overall die itself is very expensive to make.
Right.
And you have a CNC machine that's cutting it, and it could take a long time just to cut out, one side. You're going to have both
Right.
sides of the die. And then you make multiple copies of it. And of course, you have a lot of other different dies. So it may be that you're not having to keep on pressing that same part all the time, but you would take that out of your press and then put in a different one to start pressing another kind of part, because usually you don't have as many presses as parts that you need to have. But you have a lot of these dies you're going to swap out, but you're going to need to have at least 2 versions of the die, because if the die gets worn out, you need to repair it, and you need to repair it quick enough
Right.
to be able to then be used when you need it again. So usually it means you put a second die in there while you go over and do the rework. And they're going to talk about the reworking here in a second.
Right. And for people who watch the Gigacasting one, it's the same thing. They said they've got 2 that they can alternate because there's dies there too as well. And of course they get
Yes,
so these things,
yes.
they don't last forever when you're dealing with things as hard as this.
Nothing. Every mold, everything in a production environment does not last forever. The question is how long you're able to
Right.
get it to run before you have to do rework. And we'll wait for Lars to mention that.
Yeah. Okay.
Press 10 strokes per minute. That's the press that runs it. We do 8 panels inners, as Lars stated. We do tailgates, hoods, the 4 doors, lamp cans, things of that nature, but 10 strokes per minute. So roughly 600 an hour at 100%. Again, this is the front door inner, like Lars stated, dual. And then this is
The
out
lower
10,
half.
This is our draw.
In the upper half.
Wow.
Crazy.
Hmm.
That is a big big
That's
10 per minute.
that's pretty
Yeah.
nifty.
Isn't that nuts? Isn't that just absolutely crazy? And then of course we've got like kind of an opposing side, I guess, or is that
Yes.
the negative? Yeah.
The
yes.
2 sides. Yep. Yeah. The
Yeah.
positive and the negative, if you want to think of it that way, the A and the B side.
Right.
I've never really stamped stainless steel without a coating.
I don't think anyone has.
So, well,
This is our
there may
first
be,
trial.
but not me.
Certainly
We're all
not.
learning.
Certainly not for like an A surface quality part. Like there might be people making it, maybe like stainless steel pots and pans, but then they polish them, right? And they make them.
Yeah, well, yeah, polishing is that's the biggest cost with pots
Yep.
and pans.
Yep.
The stamping and whatnot, deep draw, whatever.
Super easy, right?
No problem. This though is something I've never seen before. I've never used a bronzish. What'd you call
Aluminum
this?
bronze
Aluminum
alloy.
bronze.
It's from.
How do you coat it? Is it?
It's actually the whole material. It's not coated.
This is aluminum bronze,
Yeah, like the whole. the
and
whole
you can
difference.
stamp with it.
Yeah, I mean
The
it's
whole
hardened.
material.
We have a coating on top, but like we found that it was the best material to use.
So explain that to me, because that seems absolutely it seems surreal that
Okay.
they can do that.
I thought he said that, and then for a second there's, oh, wait a minute, they must have like a hard material and they just kind of coated it. And he
Yeah.
says like, no, the whole thing through is aluminum bronze. Like,
Right.
wait a minute, yeah, how can that be? And then they somehow harden the surface on the top so they can do some sort of heat treatment or something else to make it a little bit
Right.
harder on the top.
Right.
but still, it means it's not going to survive a very long time.
No, it's crazy.
And so let's find out what they talk about here on exactly.
But it
how
is,
much,
I mean, you could hear Sandy Munro also just going like, what? That's not possible. You know?
what? You can't make the whole thing out of bronze
This
aluminum.
is first
What?
principles thinking here, people. This is like, it's like,
Yes.
just because nobody's ever done it before doesn't mean it can't be done. You just have to think about
And
it.
part of it is also
I gave
that
you
I think it's able to slip along it. So he was talking about coating like a lubricant to make it a little bit easier. They may
Yes.
be doing that as well. But I think
Right.
also the fact that that material allows the stainless steel to kind of flow over it a little bit better and not get caught up, which is going to make it very difficult for the
Yeah,
stamping
because
to
he
survive
specifically
otherwise.
talked about drag marks. Lars talked it because you don't want
Yes,
to
drag marks will be a problem, tearing,
like that.
everything. Yes.
Yeah. So
On it.
Yeah, we're still playing with lubricants.
Yeah.
What kind of oils we're using, how much of. So we're still
Really?
dialing it in.
Some lubricants.
Because when you use steel, we get drag marks. You know,
Yeah.
aluminum can't last, right? But so we obviously have to replace these inserts a reasonable amount of time, but you know, they're lasting quite a lot longer than we thought they would.
How many hits you get on this thing?
Well, how many
How
have
many
you
do you
stamped so
think you're
far?
going to get?
So far, we probably stamped about 1,000 to 1,200 of each part.
I think we're going to get about, based on our prototype trials, anywhere from 50 to 100 before we start doing rework. But you know, you rework a stamping die nominally, you know, every time you take it out a little bit. Right?
Yeah,
So
we're constantly down in quality. Our
we're not going to throw the die away. Just going to rework it, make sure the finish is there.
most of our PIS scores
Wow.
now are in the upper 80s.
PIST is our points in spec, so we try and get 100% is a perfect spec, like 0 nominal, we're upper 80s, 90s.
We're currently in the upper 80s. Started in the low to mid 70s, now in upper 80s. Every run we try to improve.
So that's worth calling out too, is that they're iterating on this, but that
Yeah.
they
Now, what they were saying, and this is where he talked about 12. Sandy was asking how many hits you get out of it, and
Right.
we're hearing like 1,000 to 1,200, and then Lars is saying, 50 to 100. Which numbers did you hear there?
but is it 50 to 100,000 that he means? Is that like I don't know, 1,000, 1,200, 50,
I mean, they were
100?
yeah, because that's a pretty small number. Because if they were
Yeah.
doing it, what was it, 10 a minute? That's every 6 seconds. That's like 5 minutes. You're done.
Yeah,
It's time to get reworked.
we got-
So, I'm not, 1,000 will be a little bit, if they said they're getting a little bit more out of it, and they said that it's like, a number like 50, I'd say, yeah, I don't think you're going to get a whole lot with such a soft material.
right.
100 seems like a small number if you have to keep on changing the dies out. Now,
Yeah.
he talked about that the dies get reworked. So they're constantly going through and they're remeasuring the dies, or they're checking something out to make sure it's within the spec. And then when it goes to get reworked, then they just have to go find the areas that it's starting to fail and build the material back up and then recut it. So that's typically what they do, is like, the first machining of the die is a very expensive thing. And then what happens is they find a lot of the low points that are going to be in there, and they used to manually weld. They would go in there and actually weld it back up.
Right.
And then it would take it over back to the CNC machine. The CNC machine
Re-weld it.
would sort of remove some of that excess material to get it back down to it was. And then it would have to go through some sort of heat treatment to get the hardness back to where you wanted. So there was a lot of work, but not like building a die from scratch.
Yeah.
Eventually the dies will wear out so completely that you have to put a completely new one in.
Right.
And I'm not sure what they're talking about with how long it needs to run, because if they're only getting 100 hits out of it, and we'd have to listen to that 2 or 3 times, I'm a bit confused. I don't think they're talking about 100,000 or 50,000. But they do seem to be talking about a small number there.
Right. And I mean, but I guess one advantage they have is, as far as I understand it, they have their own CNC die creating machinery. in the
Yeah, but it
factory, so-
still takes time,
Yeah. Yeah. You can't have to
And
be
it-
making multiple ones of those per day, which is what it sounds like you'd have to do.
Yeah, a lot of rework, and maybe they are able to rework it pretty quickly.
Yeah. Anyway, crazy numbers, but wow.
Well, there you go. Two things I would have never guessed. Yeah.
All right, let's go up
I love
the
his
stairs
reaction.
here, and we're just gonna walk
Do you
around.
guys want to see hot stamp from ground level
yeah,
or top level?
yeah, we can look at hot
Oh,
stamp.
yeah,
we-
yeah.
and then we'll walk.
My
up the
big
stairs.
thing is I want to see how you're forming.
Yeah, we're
the,
gonna go up and go
creases
show you that.
So I'm assuming the
Plus-
hot stamping part is part of what they're doing here, heating the metal is that so he said hot stamping. So are they softening the metal by
Yeah,
heat?
that's what it sounds like. Yeah,
Okay.
yeah.
Okay. So that's also a cheat. That's like a cheat code because you're not doing it with a cold material. So
Right. But I'm not sure if that's what they were using for this or not, because when you heat it up, you're probably going to lose a lot of the material properties again,
yeah, right.
which
But
would be
again,
almost,
we're
be worse
talking
than
about
the
inside part.
the cold working of it.
Yeah. But we're also talking about the inside part of right, because there's the outside pane of the door.
Yeah, I think it's a different part. Yes.
So
different
that
parts, so it
stuff
doesn't matter as
inside
much.
doesn't have to be quite as strong as the outer panel, maybe.
Right.
So,
Right. Exactly. Exactly. So the
Completely
outer
fixed.
parts, they do not want to change the properties of it. This
Yeah.
is probably all right.
Yeah. Okay. Because they are still visible. Because they do note that they're like these parts of the door. There's some plastic and covering and stuff, but there's the part of the door that actually closes against the other part is just
Mhm.
exposed stainless. It's not painted. It's not
Mhm.
not anything. So yeah. And then they talk about powder coating later. So yeah. But
So here
Right,
we
so
have
they use-
21
I wondered where that
furnaces.
black
There's,
color had come
3
from.
furnaces,
Yeah.
7 chambers each for a total of 21.
was the most logical
Yeah.
We
reason.
heat the material to 900 degrees Celsius.
Okay.
Then we put it in the press. It's one station. The upper and the lower dies are held in place for anywhere from 6 to 8 seconds with water running through each, and we're basically in a way quenching the part.
Okay. So that sounds like that's what they're doing. They're heating it up. They're squishing it between there for 6 to 8 seconds, running water through it to quench it and get it cool again. So they're definitely changing the material properties of those panels in
Mhm.
that case. So, but again, maybe it's a different kind of stainless. Maybe the outer one is the HFS and the inner one is not quite HFS.
Yeah, exactly. 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 And if they're quenching it, they might be getting the material properties back that they want.
Exactly. So yeah, so they, you get more of a liquid thing and then it recrystallizes as it cools. So yeah, again, I'm sure very, very specifically exactly how fast they cool it.
Yeah.
So,
With metal.
Yeah. Yeah.
So this is made by AP&T out of Sweden. We have a second one coming just to the west of this
Sure.
one.
okay.
So you come in here, you probably see these oven, right?
You're good.
So we got ovens here
So this here takes it off a destacker where it's centered, then it loads it into one of the 21 chambers. Then another one pulls it out and loads it into a centering table. It's
Yeah.
centered, then it gets transferred by a last feeder into the die. We can see the die over here if you'd like.
Sure. Why not?
So each
Oh,
one of
it's
these-
not working right now.
No, it is. It's just each one of them's heating up. So
Ah.
each one of those chambers is a different door with a different panel and heating up. We
So
can go to the
what's that
forming side. What's that?
How much time does it take for heating up?
We got
Like
21
15?
stations. So total strokes per minute on this is also around 10, 12, right?
This
So
one I can make.
So you say 10 per, is that right? Let me go backwards.
This
So-
one I can make. It's 23 seconds for inners, 25
Yeah.
seconds for outers. So I can make
Yeah.
144 an hour with the inners and 150 an hour with the outers.
So, and that's at 100%. So we're looking at, if you multiplied that by 10 hours a day, just to be
Mhm.
conservative. So that's 1,400 a day. I mean, that easily covers your 5,000 a week kind of
Yep.
target goal. So yeah. So, okay. So they're making them at sufficiently fast pace. So yeah.
At 100% OE. At 100%.
Yeah.
here we go. We got one coming. I hear it.
Should be one opening up soon. We may have just come at a bad
We
time.
might have just come right when they stop. Here we go.
Here you go. You want to see it? There you go. Right
So
over
yeah.
there.
So now we got,
You can see it's pulling out the hot blank right now. See that red hot blank? It's gonna get laid in. It's basically a noodle kind of right now, very, very soft. And like you put it down, we'll form it here with this gripper, and then we'll just drop it into the stamping press while it's still hot. Hit it one time. Boom.
Usually holds it for about 7 to 9 seconds.
Yeah.
One time
We can show you what
shot.
the parts
Yep.
look like.
yeah, I think she kind of pulled away from it because I think the interesting part was not the arm, but the other part where it was. But anyway, you can
Exactly.
see it.
So-
So it's definitely they're hot stamping it, which is really helps a lot in terms
Mm-hmm.
of probably also the longevity of the dies too. Because
Yes.
yeah, okay. So
When they come
Come
out.
back in. Yeah.
Yeah.
And that's the only way you could probably do it in one shot. Otherwise, you'd
Yeah, no,
have
these
to
were-
have multiple stampings.
Stanchions up.
right.
Yeah.
And it also explains because like the outer panels, they talk later. They're like, we can only bend it a tiny little bit before it starts to crack and everything. But obviously 900 centigrade is quite hot. So not melting, but
Well,
hot
it's
enough that
glowing. That's for
it's
sure.
going-
Yep.
Yeah, it's going to be very soft. So yeah.
So as you can see with all the equipment, we're ready to roll at like high volume. Now it's just like, how do we ramp? Go slow, get quality right.
Yeah.
So yeah, what do you think? I'll ask you that question. Do you think from looking at this that they're ready to go at high volume?
Oh yeah, yeah. They're definitely they have almost everything they need, and now they're just deciding what the ramp up phase is going to look like.
Right. Okay.
How quickly they want to start pushing everything. So it seems like they're pretty pleased with it. that
Yeah.
they're getting the quality that they want, and then they'll increase the speed a little bit and a little bit and a little bit. You don't want to go too fast too quickly, because then you
Right.
might break something. So
Right.
then you begin to learn, double check everything is going all right. So yeah, they're it's called a ramp for a reason, not a step.
Yeah,
A
exactly.
ramp.
So anyway, so it's just, and it is really, this is one of those things where, again, they could have delivered 10 trucks and they could have been like, hey, see, we're in production. Like, sort of like the GMC Hummer,
Mhm.
or the GM Hummer, anyway, whatever, it's like, hey, look, we're building these machines, but you're making 20, 50 of them a year or something. This is clearly not designed for this. They've clearly thought a lot about how to do this.
How do we make, the order of, hundreds of thousands of these a year? Yes.
Exactly.
Right now we're doing inners, inner left.
Okay. So this is them stamping the doors. I guess all these guys hung around after their shift too. This was very nice because it's clearly evening as they're walking around.
Thanks.
And then you get your doors.
And here's what they look like when they're done. This is a body side inner.
Check for heat.
It's gonna be a little hot. It might be a little hot.
No, it's not even warm.
Now,
This
just
will
so
cool
you
down
know,
fast.
we're actually going to unload this with a robot. We have what's called an automatic, basically using a robot to automatic racking system.
Yeah.
So
Yeah.
they're going to automatically get put in these racks, and we're going to take them off with forklifts. Right now, we're not 100% ready to do that yet.
And then they go up this conveyor, right? Well, not as these parts, all the parts. They'll go up here, and we'll go up there, and we'll show you how we form the stainless from
Yeah,
there.
so boom, we got our lift right up there. We supply body shop, which is
So obviously still things going. There's a later part where there's like a bottom of a KUKA robot and no top. So there's like a base. So they're still working on all these things. So anyway, let's see.
any other questions?
No, I've seen a lot of this. So all this stuff looks about. No, I haven't seen one this size.
We go up and over, Dan?
Yes.
Yeah, let's go up and over.
So that's pretty impressive, just watching them pull that sucker out of there. So then I guess, so that part that they're doing manually at this point is going to be roboticized.
The panels that you saw, the blanks
Yeah.
from the side will come up here
is
along with other
upstairs.
parts. And then they'll move in. Right now it's all forklift. You can see all our cherry.
So again,
pickers
that's the
and
impression I
construction
had
still here,
from
but they're coming here.
where you were
we actually have
being
the body shop
doing your
on.
tour.
Right.
As
'Cause
well,
they had those
everything
big
was
elevators.
manual right now. Eventually, they're going to be bringing more and more automation along that line. Yep.
Right. And it sounds like right now it's not going up and down is not automated. They must be doing it on some sort of elevator or cherry picker or something like that. But eventually it's going to get automated.
Second floor here.
That's
So it's our-
unusual, yeah.
Yeah. Well, it turns out those are the least number of parts now. We're down to just over 100.
Yeah.
So moving them up isn't that bad, and they're bigger, so we can get bigger, less trips, and they stack nice, so we get a lot of QPC. So we come in here to mainline, but we're going to go straight to doors because we're running low on time, just to show you doors from forming to final.
No, to finish.
So kind of zigzag.
And of course, the doors being probably the hardest part to build because there's the most structure in them and everything. So
We're only running one shift right now, and nights are doing cleanup and construction and final debug. So it's kind of quiet here, but Werner and the team were kind enough to stay for you.
Well, that's
So
very,
we can-
very
so we can
kind
get
of
it
you.
running.
Thank you.
very cool. I'm sure they were pleased to do this.
Mhm.
Get a little publicity after years of hard work. So let's see if I can.
Yeah, it's always fun to kind of show off what you've been working on.
And we got a little bit
That's
of a
basically,
casting
the
over
doors
here.
get built this way and go down straight to GA. The main line goes this way, and then gets transferred to our powder coat line. Does that black coating
Yeah.
over there. We kind of have a flow.
But you don't use Elpo, right?
What's that?
Elpo, the stuff that everybody else uses. You dip the whole car in it, basically.
No, I mean,
and
well, this is
you don't need to.
It's a soft E-coat with a wet powder just for that black area. So we only have one oven. So we do E-coat it, basically to seal it and cure the sealer. And then we, because the door rings are that boron steel, we need to coat it. So then we put the powder coat on for the aesthetic.
Okay. So yeah, so all of that stuff where we saw the black stuff in the factory tour. If people haven't seen that, watch the video. I'll link it at the end. But that's the it's a powder coating. So pretty standard stuff, it sounds like, just to protect it and give it a nice look.
We'll go this way?
Yeah,
We
we
want
go
to do
this
rear
way.
door.
Yeah. No, we can go
Okay, we'll go
here, I know that this line, bending line, was running dry cycle earlier. I think the other one next to rear door is actually running.
Okay, let's go see the rear one. So we'll talk dry cycle, I'll talk, and then you can show them the rear one. So this is our true bender. It's from Trump. Works special on this. This is the air bender I was telling you about.
This is
So
cool.
this is dry cycling right now. We have one of these for each panel. And how it works is, we'll come in here close. Currently we're running dry cycles, so you can see any faults and whatnot when we're off. So it'll pick up the panels here from that stack that the guys made in blanking. Picks up a panel, and now it's putting it, it's about to pick up a fake panel. So it picks up that panel.
Looks like you're getting suction cups.
We'll show you the one working over there. And it's gonna bring it into the true bend, which is from Trump that we worked with. And as you can see, that brake bend comes down, but that's that air bender. It has that V shape with the air flowing on either side to keep it, floating, which when you get the mar marks. Flips it around, it'll do the other side. And then once it's done, it takes a good part and puts it back on here, and it'll come out here. So we just wanted to show the dry cycling before we go over and look at the actual part, so you can get the idea of the movements.
It's very cool how it does that.
Now, again, we're in the middle of commissioning all our transfers. Usually we do that.
That's a very custom kind of robot arm specifically for press brakes like that, because it's not, I think it's like a 5-axis arm, because you don't need all the degrees of freedom you typically have specifically for press braking. And press brake is something people used to do manually. You take a piece of sheet metal, you put in there, you push down the press, and then you learn to kind of bend it. And it was kind of a learned technique on how to do it. And it has to be coordinated with the movement of that die that comes down, that actually does the press into there, and a kind of coordination with it. And by understanding how the metal is going to be deforming, they're able to sort of change the movement of the robot to be exactly tuned to it. So that's why they're very specialized piece of equipment, where it's not just a movement of that arm, but it's also figuring out what's going on with that press brake when it comes down. And it sounds like they were saying that, I guess, the part underneath, because you've got this sort of this die that's coming down the top. There's that little V shape, and they make the air coming in underneath it, so the metal never really comes in touch, in contact with the part underneath. That's the A surface. And they put it in, they bend one side, and then that arm is designed to do a 180, whoop, brings it right around, and then you do the other side.
Which is exactly what we're going to see here. And I believe they say that they're running at 25% speed here. So I think that's like, it's going very, very slowly, but so actually I'm going to, let's see if I can, well, no, it's 5X. Oops. I guess I'll 2X it here, but anyway, so you can see that that little piece in the middle is the V shape, and that gets the inside of it. And then it spins it around, and it presses the other, and there you go. And it see, it's very interesting, because you can see it kind of working it back and forth, getting that just exactly the right shape.
Sometimes you have to do it a couple of times to go around there. And so the arm itself is 5-axis, and then it's on a track, which gives it kind of a 6-axis that allows it to go back and forth to where it's picking up the different stacks.
Yeah. And of course there's also they talk about how there's like lights and everything. There's detectors that are looking at it to make sure it's bent the right amount, because again, one of the things about steel is you can bend it a certain amount, and then it'll give back again. So you have to over bend it a little bit, let it relax, and then figure out if it came back the right amount.
Yeah, actually, I might be wrong about that arm. I think that arm might actually only be 4-axis. I'm trying to look at it. It's like 1, 2. It's gonna be 3 there, and 4. I think it's just 4, because basically what's normally joint 1 and joint 4, and a typical robot arm is not in that one. So it's a 4-axis. So it is actually a total of 5, including the track.
Yeah. Okay. So
4 times the thickness, So it comes out. We'll put down the clean part here, and here we have the robot. Not quite ready, but
wow, that base is huge.
So there's the there's the robot up to the part where the end of arm tooling is, I guess. So so big boy. Why is that needed?
They make them bigger, actually.
Pardon me?
They do make them bigger.
No, but I mean, like, why do you need it that big just to pick up a door? Like that panel is not that big, so it seems like overkill. But
it could probably, for the payload, it might just be the volume, the fact that you've got a very big part that you've got to pick up from one place and move over to somewhere else.
Just so it can.
It's more of the work envelope. problem
Yeah.
as opposed to the payload. And the other thing is, remember the payload also includes your end of arm tooling. So the end of arm tooling that might be needed to pick up whatever that is, if you're picking up the entire door,
could be quite heavy.
or that frame, I think that outer frame that they were kind of showing, it could be, yeah, that itself might be pretty heavy.
Yeah. Okay. Yeah, because you also have to have the vacuum nozzles and all that kind of stuff. So there's a lot of material.
Yeah, and I'm not sure if they're using, well, what was this for? Is this for the outer panel of the door?
I believe they said, yeah, I think they were just going to pick it up and move it. That's what this thing is for.
Oh, okay. Because that should be pretty simple, because that's not a really big piece. I was thinking of those big door frames that we were seeing earlier.
Right. But again, I don't know. But again, you might be right. It might have to move it such a long distance that you need a bigger one.
Yeah, it's the reach. A lot of times the reach is going to determine the size, and then there's going to be a payload consideration also.
Right.
It's a
let's
good door.
do that.
Yeah. So door comes out. Really cool how beautifully. And what did they say? Like 4 or 5 millimeters is the radius of curvature before it. Crack.
Yeah. So depending on where the arm is going to be, it's going to reach way over to get it. I assume it's going to be in a little bit closer, but you see, it does have to reach pretty far to be able to get that.
Right. And there you can see, like, that's a pretty crisp bend right there. And obviously, I mean, this is not a light part. You think of, you're like, oh, aluminum on a door, that's very light, but it's taking 2 guys to pick this up right here. So
it's stainless steel. Yeah. Steel, I think, is 3 times more dense than aluminum, if I remember.
Right. So I mean, what's the limit for factory workers? About 50 pounds per person, 45, something like that. So
I think it might be something like, I mean, obviously they can lift more, but usually they don't want you lifting more than 50 pounds.
Right.
It's the same at the airlines. The reason why the baggage limit is at 50 pounds, you have to pay extra to do a little bit more. And then that suitcase has to be handled differently because 75 pounds or something, whatever that is going to be a lot.
Yeah. You have to remember that you got to do this for 8 or 10 hours a day. So
it may seem easy. It's like, oh, come on, anyone can lift up 50 pounds, but try doing that for 8 hours straight.
Yeah, it's like, that's going to suck. So,
and this is ready, as I said, right now we're putting them in the racks. Well, they ran out of racks.
It really does look beautiful.
But you want to put it in the check fixture?
So also
I put it in the check.
The rack here, notice that the rack doesn't let them touch each other. So they're not just like stacked up like books and rubbing and messing up. So
Yes, exactly.
Look at it?
Yeah,
sure. Great.
So I'm gonna speed this up just a little bit, but they put it into this like little. I guess it's maybe a tester or something.
Yes, right there, exactly.
This is the internet. You can see we got a little more in
to
here.
validate the dimensions.
What I was concerned about, or what I was thinking about, was just the outside bruising, not the inside. I don't care about it.
I mean, you can see on these panels over here.
So again, if it gets bruised on the inside, no big deal.
You can see where the air's blowing off the dust.
Yeah.
But you come over here, nothing.
So yeah, one's got its little spot to sit in.
Yeah, that's pretty amazing. Actually,
you got the truck that Sandy touched.
You're using 2 of my favorite, 3 actually, counting Kuka. They're my
Trump,
go-to.
Kuka, Schuler.
Yeah, if I'm gonna do something, I hate screwing around with junk.
Yeah.
And anytime a purchasing agent or one of those engineers with an MBA says, "Well, I got a good price on it," I have an expression.
There's usually a reason.
Don't save me any money. I can't afford it, and that's the truth. So.
By the way, these are 1.8 millimeters thick.
These are the full real bulletproof.
Everything else is 1.4 millimeters thick, other than the doors.
Yeah. Well, you need that extra for the machine gun. Yeah.
Well, the 1.4 is actually pretty bullet resistant.
Do you remember
too.
Salada tea bags?
This is actually.
When I was a kid, my parents always drank Salada tea, and it was like a Chinese fortune cookie because it always had an expression on it.
Right.
I remember one of them that was on there was, "The one thing you can't afford is a bargain."
So that's exactly it. So yeah, exactly.
It's kind of true. It's like, it's because it's a bargain, you decide to spend the money, but otherwise you wouldn't have.
But yeah, but I think this is where he talks about the side impact crash resistance of the.
It takes about 75% of the side crash loads.
Right there.
Just through the panels itself.
So that's impressive.
So we wanted that extra thickness for the stiffness.
I mean, that's just a crazy thing to think that somebody can T-bone you and 75% of that energy is dissipated by just that outer panel.
Just the door, yeah.
That's impressive.
So after it goes over conveyance, we'll go into the weld cell, and then we'll finish it.
And then finally we get to welding.
So that's one of the things I'm really interested in. How do you affix that to the
Let's go check it
for the
out.
rest of the
How
door.
do we fix it? So we have the inner, you saw from downstairs. We have the outer.
Yeah, we were all interested in how you fix it.
Exactly.
Now we got to put them together.
Right. Without making any marks.
Right, super easy, huh?
Ah, you piece of cake.
Hey, but at least it's not aluminum to steel, because we were like, how the hell do you weld aluminum to steel? But,
Right.
we
And
now know,
because it's steel to steel, you don't have to worry about the thermal expansion rates being different or anything else.
exactly. Yeah.
So we load the inners in here. Is this running now? Is this all? This is all off now, right? Maybe?
What's
Looks
that?
like it. Want to check? He's going to see if he can turn it on for you. So basically, you know, we don't have any reinforcements on the exterior panels.
Yeah.
We have a couple of hinge reinforcements just
Right.
locally on the inner. So this cell here takes that inner panel and this hinge reinforcement and just welds it together. A couple of spot welds, that's it.
Okay.
Pretty traditional.
Yeah, but how do you do it without any marks or any?
Just keep going.
Yeah. Oh. Okay.
Yeah, the line is full right now, so we cannot.
Oh, the line's full, so we can't. Okay. So now we bring the outer in. Okay. Outer comes in here, gets loaded in here, and we have another laser booth. And the laser booth, because the exterior surface was the most critical, right? We didn't want to get any burn through, mark through, see
Right.
through.
Yeah.
So the
You don't want a blue mark either.
So the tolerances have to be basically micron level precision.
Yeah.
In order to get the two together. Do you have the one part here, Aaron?
Yeah, we got a part here.
Yeah. So this is all closed up laser, but you can see the line's full here, so that's why it's not moving. We can come in here, it's fine. So this is a part as it comes out, and you can see the laser welds coming here. So we actually clamp down on all the corners.
So interestingly enough, it looks like there is a little bit of a clamping sort of thing. This is kind of
Laser-
like right there, or is that just part of the die itself?
Oh, that's probably they'll hold it in place during
Yeah.
the welding process, and
Right.
then they get released.
But I was a little unclear whether the other place was just spot welds, but I couldn't tell whether they meant they actually do a weld around the entire ring of this.
I think so. I
okay.
think so.
But again, it's you're heating up just the inner surfaces, not so you're
Just
talking
enough
about
to get the weld.
1.8 millimeters. It's got to go through like half of that or something.
Mhm.
Because if it does, if it goes through more than that, of course, you end up with some sort of discoloration or something on the
Yeah,
box.
the blue marking that Sandy was talking about on the other side.
Which, by the way, if you have fancy watches, they talk about heat bluing the hands of the watches, and that's exactly they just heat it up to a certain temperature and it turns blue. So there you go.
It's going all the way around the perimeter. And what that does, I should really.
I already got it now.
Close.
I didn't think of that.
So it comes around the perimeter. It actually bends this in just ever so slightly, gives it a little roundness. Helps
Right.
with the A-surface light coming off the side, so you aren't edge to edge. You got a little tip. But
That's a cool little design feature right there, that you don't exactly match up the edges because you'll see any kind of flaws, but that they have like that little rounding to it. So
we don't get it. We had to work, I don't know, for months on the current and the heat that's going in, so we don't get burned through with tolerance and
Right.
whatnot.
Yeah.
Yep.
Trail off. But that's it. It's that
Months.
simple, and we're done. But now you'll see, like, we do have some burn marks here. What we do is we go into laser ablation, and we just kind of go
Right.
clean it all up.
And
that's pretty cool too, by the way. So any kind of marks they get on the inside, they just go zit, 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 and they just take it and
Yeah, they can get that
Ablate it.
off, but still, you see, it took them months to figure out the current and everything they
Oh,
needed to be
gosh,
able to
yes.
get it to not burn through. That's
yeah, I mean,
welding is a really difficult process to
Right.
master, and I'm not aware of like any simulation software that's perfect enough to be able to tell you exactly what your settings have to be.
Yeah,
Everyone's been working on that. They can get a kind of a good guess, but in the end, you have to go and fine tune it.
and they probably just had to scrap a lot of metal while they were working on it. It's like, nope, yep, nope, yep. Also, this, as we suspected, is the sound vibration dampener, that little like
Yeah,
plastic.
exactly. And you'll see those on stainless steel sinks.
Yeah, yeah. And I
Yeah.
believe there's some in like dishwashers and stuff too, right? I think if you get a high-end
Yeah,
dishwasher.
there may be also in places like that. But yeah, I think you put that under sinks. You can go to Best Buy and buy those, if you're having a problem with, because sometimes with like the garbage disposal that you might have on your sink, it'll vibrate and you just put that little damper on it.
Right. Yeah, it's
I think, did he call it an oil damper or something like that? So it might actually have
I
like a
swear he called it
material
a drum. I think he's going to say that in just a second here.
I thought maybe you were going to do with the outside of this thing. So I noticed you got 2 vibration
Yeah,
patches.
it's just big oil can, right?
Yeah.
It's just a little damper.
Oil can. So I guess maybe it's just filled with some sort of fluid, some oil.
It's an oil damper, yeah. So
Yeah.
it probably has like oil in there. Yeah.
Yeah. So again, you know, the vibration is just going to get absorbed by that. And liquid is really good at absorbing vibrations because it doesn't really want to, it doesn't have a resonant frequency basically.
And the other thing is the location of where they put that. So they
Yes.
figured out where's the ideal location to stick that to actually dampen the whole thing.
Right.
So you look like where you're kind of a point of resonance that you're going to have in there. It's like, whoop, we put it right there and that will dampen everything.
Yeah. You can imagine like standing waves and stuff. And like they could start over here, go over to here. So you're kind of trying to tune it exactly. So yeah, which makes it quiet.
And that's another thing that was going to be a question, but now it isn't. Okay.
So we come out of laser weld, we go into a holding cell because we have a buffer, basically just a buffer.
Yeah.
And then we come over here to finishing. And all these lines are integrated together by Bernard's team and the guys because, you know, actually every station, you can even see with the robots here, finishing station as KUKA, welding station as FANUC. They're actually from different companies because we like to like spread it out to people that are good at what they do, right? And so then we come in here to finishing. You want to explain how finishing works a little bit, or?
Yeah, sure. So from welding, we drop it in our handover stand there. Robots will pick it up, drop it in a stand, and we got robots on the other side. They have like a buffing pad.
You see on the bottom of that head that's like inside the shaker, you see those, it's 2 Brillo pads basically, hanging down there. Actually 3, right? Three across.
Yeah, I see it.
And all that does is very lightly goes across, back and forth.
Yeah, it does a couple of runs over the complete door, and then they use a different type of pad for the other robot, and then this is a completed part after finishing.
This is what it looks like, done and done.
So I think that's he talks to them for a little while longer, but it's just kind of conclusion stuff. But so basically this point, there's no paint, there's no primer. This thing it gets put onto the truck and it drives off the assembly line, you know, that's it. They don't have to do anything else. So this isn't officially like unboxed, but it is kind of similar to that in the sense that you're building these parts without having to rework them afterwards. And of course you still have to put in all the plastic inserts and all that stuff, you know, the door handle and all that kind of stuff. But in terms of the main structure of that door, it's just done. And there's nothing else.
It's ready to be mounted onto the vehicle.
Yeah.
Again, some nice little polishing and buffing that they go in there to make sure it has the right finish.
Right.
One of the things that Lars was talking about there is that they will have these different integrators that are coming in and bidding for different parts of different projects, and they're specialists usually in some things. You'll have those who might be specialists like laser welding or a handling system.
Right.
And whoever gets that, it's like whatever your competency is, and a lot of it may be an integrator for a certain robot brand.
Right.
And in some cases, the integrators may be told, you have to use this robot, which means they have to become familiar with more than one kind of controller. But it seems like Tesla's like, no, we don't care. Is that that because the 2 different lines are coming together. There's no reason why they have to be the same branded robot. They could be different.
Right.
And if you guys that are running it are specialists on that, then that's fine. Now, of course, what that means is that within Tesla, you have to make sure there are people that know how to run those different robot systems. Because at some point, you know, when the system is up and running, it's not the integrator that's coming out and playing with the robot. You've got to have your own people. So you're going to have different groups of people that are trained on that, which is why when you go to a lot of factories, a lot of times they may just be one robot brand type. Because the OEM has decided, oh, we don't want to have these guys knowing 3 different robot languages and how the controllers work and all this. It's like, oh, we just want to train everyone on that. And Tesla's like, no, what we want is we want every one of those to be the best process that's tuned by people who have the excellence in that, and we'll deal with that. That's fine.
Right. Yeah. So basically, they put the pressure goes onto their own employees to figure it out afterwards.
Yeah, but in the end, it's not that hard, you know, for someone to know how to use a FANUC robot or a KUKA robot. But in many cases, it's just like, oh, you know, another guy has to get another certification course and being able to do it. But the thing is, you've got teams of different people that will be specialists on one particular brand of robot, and some other people that are, you know, bilingual, trilingual when it comes to those different controllers.
Right. So all very cool. So any final thoughts? I have to go because I have to get to another meeting, but any final thoughts on it's just
No,
impressive.
it's definitely a video watch
Yeah.
worth watching. And, you know, just
Watch it again.
the lots of little
Watch it
tidbits. And again, I wanted to see how many hits they were talking about there because I'm really confused. Was it 1,200 or 50 or 100? And what they're getting out of it?
There's a big difference between 100 and 1,200.
Oh yeah, yeah. Especially if you had to do a lot of rework.
Yeah.
1,200 might get you like, you know, through the day or something like that without
Right.
having to do it. 50 or 100 is like every couple hours, boy, or every hour we have to, or even sooner than that, we have to rework this die.
So we will see. Anyway, a big thanks to Munro and Associates, and of course to Tesla for being super transparent, and of course to Scott. Make sure you follow Scott on Twitter or X, excuse me. I'll put a link to his account there, and definitely do that. While you're there, like and subscribe, you know, all of that good stuff, and we will see you guys in the next video. Bye-bye.
Bye now.